All right, if you buy a BC348, some of them come with a power supply. The radio could be wired. The filaments got rewired for 6 volts. And on the pictures for eBay, you'll see some type of power supply. Let me show you what it'll look like. You'll see something like this sitting down in this spot here. You'll see an old transformer, maybe a tubular can capacitor, and then a 5U4 or 5Y3, all right? And this transformer will produce 6.3 volts, 5 volts, and then high voltage. So that's what they were doing. These guys were making power supplies. They were gutting the dynamotor. Here's the real dynamotor. It's very heavy. All right. Notice it's got a box underneath. It's mounted with screws that stay on it. All right. Very heavy. In here are chokes and capacitors, and that's to keep the motor whine, the dynamotor whine, off the radio. Okay. Anytime you make a power supply, whether it be a switcher or a dynamotor type, you're going to have noise. One from the motor on a dynamotor, and you're going to have from a switching supply, you're going to have noise. Now, if you build a analog supply, that's the best for this radio, and that's what a lot of guys did do. Now, in order to get that dynamotor out, there's a rod. You can't get to the 2 screws when that dynamotor's in there. You got to pull this rod out. See that rod that's moving? Okay. There's a little clip thing that you have to press in with a screwdriver. And once you press that in, let's see if I can do it blind. Once you press that in, or out, I should say out, it'll let you remove the thing. Now I'm going to need a flashlight. All right, I got it out of the way, and now you can pull the rod out. That's one of the tricks. The other trick on the dynamotors, after you undo the screws, undo these terminals, pull your lugs off and put these back in. If you don't screw these back in, this dynamotor won't come out. That's another trick. I don't think anybody told you. You'll be clunking and banging for a while before you figure out what the hell's going on. Now, I did build a power supply for this unit originally, and what's one of the important things is this terminal strip mounting it. This is built on a piece of 1-inch trim channel. So regular, I've used 4 terminals instead of 5. 2 are the AC, 24 volts, so like the filament, and then the high voltage. And remember, the high voltage, the minus, does not go to ground. It goes into the radio, and then the radio sends it through a resistor to ground, and that creates a bunch of voltage drops for other parts of the radio. And if you put your minus high voltage to ground, the radio will work, but you'll have distortion in the audio. That's a trick, okay? Now, the other trick I want to remind you about is on the back of the radio. It will be down in here, a Jones plug, down there, right here. Pins 2 and 6 have to be jumpered, or the front end of this radio will not work. And what it does is when it's jumpered, it puts the radio into receive mode. Normally this jumper is inside a connector, which goes over to the transmitter. So during transmission, the front end of this radio is shut off. Well, if you don't have the transmitter or the right cabling, these 2 and 6 won't be jumpered, and this radio will not receive. And I guarantee you, there are people that have one of these radios that works, but they couldn't get it to work because they don't know that trick. All right? And I had people make comments, "Oh, I knew about that jumper. Gee, if you did so much reading, you're so good. How come you didn't know about the jumper?" Go look through the literature and see how long it takes you to find it. It's on one of the schematics, and it says do not jump it out. Okay? on the connector. Make a jumper. That way, when you're done, if you sell the radio, then what happens? The person sees that jumper. They pull that jumper off. Now they put the connector in for the transmitter, and now the set works together. Okay, so we covered the original dynamotor. You probably never see one. I got one. Guy sold me this radio with the dynamotor. All right, so I got to recap it in that box below the dynamotor. There's capacitors that were leaky. They had to be changed. I fired this radio up using the dynamotor. It needs a really large 24 volt DC supply. So that's why you convert this radio over to an AC, okay, because it makes life a lot simpler. But what they did to people was they got everybody to rewire the filaments so they'd be 6 volts, so they could use a cheap transformer. Well, you get the radio, and maybe you go with 6 volts for the filament. Maybe you're a purist like me, you end up redoing it for 24. I don't know if there were 24 volt transformers available back then. I don't know. All right, but I wanted to show you, if you watched my last video, I messed around with this box, and I didn't have the ability to bend correctly. I have the Harbor Freight bending brake, but it does fit in there. Okay, I'm not happy with it. So I'm building a metal plate. It's going to be 3 3/4 inches by 6 1/8. And I have 1 inch under here. See, it doesn't look like that cavity is that deep, but it is. It's 1 inch from the top of these screws. Actually, these are the bottom of the screws. These sharp screws to the bottom of the plate, approximately 1 inch. So I'm going back to the single plate idea, like the people did that stole the plate from the dynamotor. I'm going to go back. I've built one of these power supplies. Actually, this is supply number 2. See this plate? This plate is a flat piece of aluminum. It's 3 3/4 inches by 6 1/8. All right, and I'm building another one. I'm going to steal this connector off this one, and then this guy. Okay, and I got the new transformer. I'm doing this video over, so I might be repeating myself. Sorry about that. The first video screwed up, and I have to do it over again. Here's the triad. I got another one. This is 120 to 220, and we use it backwards. We put 110 into it to get 220 AC, which then goes into our full wave bridge, which then goes into a capacitor, through a resistor to another capacitor, then to the radio. Very simple power supply to make the high voltage. The 24 volts is another triad transformer, but it's 1 amp, 24 volts AC. All right, and that lights the tubes. So 2 modern transformers will run this radio, and that's it for this section. All right, I've been doing this video in sections. Each time I accomplish something, I make another video, which I'll tie in with the other. Now, here's the plate you're going to have to make, and like I told you, it's 3 3/4 inch wide. The length is 6 1/8 inch. All right. Now it needs 4 holes, 4 corner holes. All right. But it also needs this alignment hole. Why it's there, I don't know. It just makes things a little bit annoying. But these 4 outer holes are a number 16, which is a loose fit for a number 832 bolt. Okay. This uses 832 bolts. Now, you want to, after you make this, you want to put it in there, of course, and make sure the all 4 holes line up, and that you can get 4 bolts into it. Okay, I've already done that. But in other words, these outer holes are the 2 from here to here. These 2 are 2 inches and 5/16 apart. Yeah, it's a real fraction. Then the other longer distance between the centers are 5 13/16 apart. Now there's one that just rolls off your tongue, and you got to lay it out. And some of you might not have that skill, and it's going to be very frustrating. I mean, it's a simple piece of aluminum. Okay, in this case, this is 20 gauge. And then there's two more holes that have to be put in for the, I'll show you that. Two more holes have to be put in for, I use trim channel to hold the terminal strip. All right, so that's as far as we're going to go on this part of the video. Now, I also want to mention to you, the other day, there was a BC348 on eBay, and it looked like it sat in a real dirty place without the cover on it. So it was really filled with junk. It had been bodged. It's got extra holes drilled in it. It might have a power supply, but I want to tell you about it. It was sitting at like $32, and I'm like, I clicked on eBay to, in other words, to save it. I wanted to keep checking on it. And somebody was driving it up $2 at a time. All right. So finally we got up to 63 bucks, whatever it was. And the guy basically took the auction down because he was the last bidder. The guy was bidding it up. So it seems like the price of these radios might be dropping off for two reasons. It's like housing. Housing is dropping off. Cars are dropping off. Big purchase prices are dropping off. People are being very careful with their money. All right. And the other thing was these radios were way overpriced. Okay. Now I told you I got one. I think it was 250 bucks shipping and everything, or 300 shipping and everything. That's this one here. Came with the dynamotor. Had to be totally recapped. Okay. And I made a power supply to run the dynamotor. It works. And the next step is building it. It had a power supply. I'm building a nicer power supply for it. But I just want to tell you, be very careful on eBay. You know, somebody gave me a thumbs down on my video that warns you about eBay. It's probably a dealer. Got to remember, if there's something really good at a great price on eBay, another dealer is going to snatch it up. Okay, you're sitting there, oh, I got it, almost got it, almost got it. He knows exactly how much it should go for. He puts that at the last second. So you keep trying to come up to figure out what it is. He knows what it's worth to him. And you're not going to spend that much because he knows he can turn it around real quick and sell it to someone not on eBay. Maybe at the next ham flea market or whatever. Or he needs the parts, whatever it is. But that's this section. I just want to tell you, yeah, this is just a simple aluminum plate. And even I have trouble. I have to cut this with a nibbling tool and then belt sand it in. It takes me a while. And I try to do a step each day. Like the first day, I might lay this part out and then double check it, triple check it, then cut it out. And then that's it for that day. I don't go any further. I'm very careful because I don't want to make this part over. And this part is supposed to be 6 1/4 inches, 6 1/8 inch long, and I made it 6 1/4. So when I was laying out the holes, didn't look right. I'm like, what is going on? And I caught it. I had made it an 1/8 inch too long, and I'm like, oh man, I didn't. Here's my phone. I think that's it. All right, that's it for now. On the last few words of this video, just before this. That phone call was a fake United Healthcare company. I told the woman, I said, I don't answer any questions because I don't know who, I'm not sure you're who you say you are. She got all upset. And I said, have a nice day. Hung up on her. But here, we put this ruler across here, and it's about 1 inch of depth down. This is a void, and this is where the capacitors are going to go. Now, I showed you in the last segment, told you the dimensions. You know, obviously, if you buy the radio, you're going to figure most of this out. But here's the edge connector, or the terminal. I salvaged off the other supply. I'm not building this again. There's a piece of trim channel. You can make a piece of aluminum, an L shaped. And this needs to be in such a position that when it goes down in here, all right, all right, it's in. Everything is lined up. You can access it. See where my fingers are back here? There's a window you can look in, and you can move the wires onto the terminal and tighten them down. It's exactly the same as a dynamotor chassis. Okay, and that's why a lot of the guys took a dynamotor unit and they stripped it down and they used the mounting plate, because to make a plate like I just did, it's a lot of work. All right, and I still have to decide where I want to put my transformers. Okay, you know, I have 2 transformers that are going to go on here, and instead of the power supply, the caps not being in here, they're going to be underneath. So anytime I pick this supply up, I can pick it up by the transformer and lift it out without messing up the capacitor and resistor. See, every time I grab in the other one to move it, I was bending the capacitors. Okay, but think about how much work I have to do just to get back to where I was. All right, but that's the art of radios. And I tell you, I built a lot of things 3 times. And I keep saying, how can I make it better? How can I make this easier to make? How can I do this? How can I do that? Where other people, they build as they go, and it looks like they built as they go when they show you something. And I told you there's radios on eBay that do have some kind of power supply down in there. And it's usually, if you look real close, you can tell the ones that are actually built on a dynamotor chassis, which I showed you in this video. I showed you what that thing looks like. So this is it for today for me. I'm cleaning up after the mess I made just to make this plate. You know, got to get tools out, got to cut. Then I had to look for some bolts, 832 bolts, making sure my hole alignments are all good. You know, nothing worse than building the supply up and then going to mount it and the holes don't line up. You know, I had to fudge one a little tiny bit with a round rat tail file, but you know, it is what it is. And the dimensions between these holes is not in the manual. I thought it was, but it's not. They show you the dynamotor and the plate, and depending on which manual you get, and they tell you what, you know, about there'd be chokes for to keep the line from the motor from getting onto the radio itself. Now, here's a funny thing. When I worked in Radio Shack, we had this guy that worked there with me. He kept telling me, all right, you want to run a wire from the battery into the car directly to the CB radio. You won't get any drop in voltage. Well, there's a problem. First of all, there's a problem with that. That idea is good for like a ham radio, 100 watts. But a 3-watt CB radio, you run the wire in, and you turn the car on, you go for a ride, and you hear real light in the background, and they come in the store, and then they say something to me like, I get this whine noise. And then this guy would go over and get them this big stupid thing. It was a filter to get rid of generator or alternator whine. What's really happened is you're supposed to put the CB set onto accessories. Okay, first of all, the accessories goes on and off with the key. If you put it to bat on the box, it would be on all the time. Now you do turn the radio off, or you pull it out on a quick mount back in the old days. So it would technically not drain the battery down. But bat is battery. Accessories, there's some capacitors and a choke up in this block, and that gets rid of the generator whine. But if you want to run a wire all the way out to the battery, so you get extra current, there won't be any drop. It's negligible, because I went and I did the math. You know, I went and got the meter out and the whole thing, and it wasn't worth doing it. Okay, but this is the stuff that goes around. You know, well, I did it, and I got more power out. Yeah. When you're running 100 watts or 50 watts, yes. But a CB radio, what was it, 3.5 watts, whatever they were, maybe 5 in. I think they were 5 watt to the final, and then a really good set would give you 4 out, something like that, watts out. And you figure the current out and the drop, and then look at the fuse in there, how thin that wire is. The whole thing was laughable. But it was probably an old ham radio story that run the wire from the battery of the car all the way in through the firewall. It's a lot of work. Some cars it's really hard to do. All right, that's it for this section. Hopefully we get to the next section. All right, I added the one. What, it's even got a price on the top of it. Wow, huh? What does this say? Electronics warehouse. Okay, $9.95. I wonder what I paid for it. Well, anyway, I got the transformer mounted. It's the 24 volt at 1 amp. Okay, now this power supply is different than that other one that I built. Okay, the real estate that I need to save is on the bottom. So notice the two wires that come down to the connector for the 24 volts, instead of coming down back here, that'll take away my real estate. Am I in the frame here? This camera, I really hate it, this camera. All right, here's the real estate here. So in other words, the next transformer is going to have its wires coming down up here. And that'll leave me a real estate to mount my capacitor, my resistor, and a full-wave diode, a full-wave bridge diode. But two wires come down. I use it. Notice I use a rubber grommet. And on these Chinese transformers, I saw this wire move up in here. So they don't add the shellac in there. So you got to watch these transformers. You know, China on the label. I warn you all the time. This transformer is made by Triad, and they've been around a long time. But of course, you know, everybody makes overseas now. But just wanted to tell you that's where the transformer goes. The first one. Now you lay that down in there. You know, I know some people love the eye candy. They love seeing someone else make stuff. Here's that story. If a bulb ever breaks in the socket, a lamp, you turn the bulb in. When you go to unscrew it, just the glass comes up and the socket is still in there. They tell you use one shows as potato, another one says use a cork. Yeah, where are you going to get a freaking cork? Yeah, you got friends that drink a lot of wine, and most of everybody's buying the screw top. Right. Well, here's how you do it. You get yourself a piece of PVC pipe. You turn the end down, and you put some filing grooves in here, and that's for grippers. And this unscrewed the base. It did work. It was in there tight, and I got it loose. Now the next problem is it started to rain on me. I mean, pour on me as I'm doing. I'm like, you know what? This ain't gonna work. Before I went over to the dollar store, I checked the radar. It was fine. Okay, it was all off to the west. So I got over to the dollar store and back as fast as I could. And I decided to make this tool. By the time I got the tool made and got the socket where it actually comes up, it doesn't stay stuck to this. Now probably if I put some double sticky tape on here, okay, and then go one more time, it'll stick to this and it'll come out. But it's one of them lights that's on the side of the house. It's a light bulb the light that's in other words, it's triggered if somebody comes by. And I noticed the other night we had a lightning storm. And normally that sets the light off. It goes on and off with the light. It didn't. I said, that light bulb's gone. So I went out and I tried to get it to come on. It wouldn't. Of course, the bulb, as I tried to unscrew the bulb unscrewed without the base. Okay. Then I started looking, and everybody's got this great idea, the bullshit information. Okay. Especially on the home improvements. It was part of a joke. But in other words, they're showing you a lamp that's in the house. What do you do when this thing's mounted on the side of a building? Well, that's what you do with this. Now, I don't know if the double sticky is going to work. You know, my luck, the double sticky will stick to the base, and then when I lift this up, it won't come. But I think if I jiggle it, it'll come. But it keeps raining out, and I'm not doing that. I'm doing this video. And like I said, this supply is different than the other one I got in the other radio. Just the fact that I want the parts underneath in the void. All right, that's it. I think this is section 5. All right, I got the power supply guts done. And you have a full-wave bridge here. All these parts have been recycled. I've added leads onto them. That's why they look a little funky. I used what I had. Okay. Now, each one of these capacitors is 47 microfarads at 600 volts. This full-wave bridge is good to 800 volts at 4 amps. this large resistor is 500 ohms at 20 watts. So the AC comes in, it would come through this hole here. 2 leads would come up and go in here and deliver like about 200 volts. Goes to the full wave bridge. It then goes between minus and the plus of this capacitor. Then it goes from between minus and plus. The minus goes through this resistor, minus and plus, and out. So out of here comes 2 wires, a minus and a plus. Remember, there is no ground. This thing is totally isolated from the AC and from ground. And then the 2 leads go into the radio, and then the radio delivers the minus to the resistor, which eventually makes it to ground. It's just the way they do it. Okay? So effectively, this circuit here puts out 220 volts DC, isolated from ground. Okay? Now, as far as where does it get mounted, remember I talked about the real estate. This is the bottom side. Both transformers are mounted. All right? This is the part that goes in the void of the chassis. Just like that. These 2 wires come up over here. Okay, they light the filaments. So there'll be 2 wires into here, 2 wires over to here. Over here. I got this upside down. Whatever it is. But here's the power supply. That's how simple it is. Now, there are people who say, there's no choke. Well, there's no choke in the Helicrafters power supply that was made for the BC348. If you look around, I believe it's Helicrafters. They made a drop-in power supply for the BC348. And some people have been lucky enough to get them. There is no choke. Now, what you rely on for low ripple noise is the larger 47 microfarad caps. It's with the resistor in there, it's a pi network that reduces it. Works very well. Now, if you want to kill yourself, go ahead a choke in this. But, you know, this is a modern supply using parts that you can buy now. You know, these parts here come out of different units that I worked on. Okay, I recycled them, and they're good parts. Okay, I think that's it for this section. The final section on this video will be the thing wired up and working. All right, I got the power supply all wired up. There should be no real shock when I turn it on because it's basically the same as the other one I built, except the capacitors, full wave bridge and that are underneath. Now let me see if we can get a good picture of this without there being any glare. Okay, now on the last part of this video, a minute or so ago, I said that the minus went through the resistor. The positive goes through. The 120 volts AC goes into the full wave bridge. It makes 220 volts DC. Now a lot of you are going to, oh, it's more than that. Yeah, approximately. And then the 220 goes to DC, goes to first capacitor. Then it goes out of resistor over to another capacitor, and then out to the radio. Okay, and then once again, I'll tell you, over here is plus and minus. It's not ground and plus, it's plus and minus. It simulates exactly the way the dynamotor works. The dynamotor's output, the 220 volts DC, does not have a ground. It gets its ground in the right place from the radio itself. Okay, if you take a separate power supply and run a BC348, you might have problems grounding through your ground. As soon as you add the ground to the radio, the audio is going to become distorted because your power supply needs to put out an isolated 220 volts DC. Okay, and that's about it. But if we flip this here one more time, this is a Heiko grommet, piece of trim channel that holds the restraint of the line. This is the 24 volt that lights the filament, and this is the reversed isolation transformer. So 110 to 220, and we run it backwards to get 220. And it can do that. A lot of people read the groups. They use these for small guitar amps. And here's a white wire that goes to the chassis of the radio, and it's a shield inside this transformer. I don't know what it's for. All right, that's it for this section. The next section, it'll be in operation. All right. All right, I can't leave it on too long because we'll get hit with a copyright. Let me go off the station because that freaking thing on YouTube's pretty accurate. Now here, you take pin number 3 and tie it to pin number 2. So with my design, yes, even though there's only 4 terminals, the original radio works. And you can see it's really dirty in here. This radio has been repainted and re-lettered, and I don't know, there's a lot to this, but this thing has dirt inside. I've noticed a few other things. Definitely somebody worked on it to make it look better than it really was, but I got it for a pretty good deal. The front, there's no holes drilled on it that I can find. I wanted to show you that. You see that neon bulb? Let's see, it's in the frame. See it glowing? That's a regulator, believe it or not. It's not to light the front panel of the radio. It's to regulate one of the voltages, and I believe it's for the main oscillator to keep it from drifting. And I want to show you here's the power supply sitting in the radio. Just give some more music. Oh wait, let's go back on frequency. Okay, hopefully the copyright doesn't nail me, but I finished it. Okay, and hopefully this project will inspire you to build a radio. And I want to tell you the voltage is 230 volts out of that circuit. Okay, now there's a lot of guys, if you go read the thing, I just use a transformer, I'm running mine at 500 volts, and then you'll see other people buy the radio on eBay, and they'll complain all the resistors are screwed up. That's because someone overvoltaged the radio. These things have been bodged so bad by people. You know, instead of the guy looking for another transformer that's lower voltage, he just puts in what he can find. They use 5Y3, 5U4, and they just blast it. And you see some of the people actually make a comment on some of the older forums. Will say, you know, that's too much voltage for that radio. That's even higher than the caps in the radio can handle. And the person don't care. The radio, they turned it on, it makes noise. And the other thing I want to tell you is, you know, remember I told you use a speaker. Now I'm using a much larger speaker. There it is. There, let's get in the frame. A larger speaker, even though it's a PA speaker, it's more efficient. You get more sound, and if your ears are older, the sound will be more pleasant than a smaller speaker. Okay, and the reason I went to the bigger speaker, that speaker there was for an ICOM R71A. I was working on it. I found out that's my posting up on the internet. They put the wrong value capacitor in an R71A. And there were people that actually, you send the radio to them, and they change all the capacitors in the audio section with polystyrenes in order to make the audio better. The real problem is that when they designed it, they put like a 0.1 capacitor in instead of 0.001. Okay, and I showed in one of the videos I had up there, I show how to go in and just disconnect a wire on one of the connectors to take that cap out of the circuit. And in the interim of me working to get better and better sound on the R71A, I bought this PA speaker. Now, PA speaker, in this case, is like a 5-watt speaker. It's very efficient. It's very, it's got the range of frequency range is in the mid-range area, but it's very pleasant to the ear from AM. It's like having a car radio speaker. an old AM car radio speaker. Very nice. You can hear the music as good as it was meant to be heard on an AM radio. But I did get the power supply done. I'm rambling on here because I really love radios. And the only thing I haven't been able to do so far is to send one of these BC348s back in time to myself. I think that's it. All right, that's really it.